Let's focus our attention on trying understanding how we can remove elements from the set. Okay, so for removing elements from the set, we have this command called discard. So if I say my set dot discard, and let's say we want to remove the element 9, and now if we check my set, we would not have this element 9 anymore. It has been discarded. The other way we can do the same operation is by using the command called remove. So inside the remove method, let's just put in the number 1 this time. So we're removing the first element. Okay, that is we would have the set have only elements 2, 3, 5 and so on. So this element 1 would be removed and we can cross check. Okay, now there's one interesting thing that would happen uh, when you try and remove something which is not present. So for example, now that we have removed the element 1, let's try and run this command once again and see what happens, what Python has to tell. Okay, so here I'll simply say myset.remove and again I'll pass in the element 1. So we get a key error. So Python clearly states that this element 1 is not present in my set. Like we're seeing in line 18, 1 is not present. And still we have asked Python to remove 1. So it is telling us a key error that 1 doesn't exist. But this error is not seen when you're actually using the command of discard. So let's see what I mean. So when I said discard 1, since we saw an error in remove method, we would expect the same kind of error when we are running the discard method. But this does not happen. Okay, Python will simply run this without giving us any kind of error, even though this particular set doesn't have this particular element 1. Okay, so it's always best to use this remove method and try and remove the element so that you'd have a clear idea as to whether the element is present or not. Okay, fine. Now the other method that is used is the pop method. But pop method, like we have used the pop method both in lists and dictionaries, but I wouldn't suggest using the pop method on sets. And the reason for that is because the sets do not have any order. So when I use the pop method, what Python does is it arbitrarily chooses some element and it pops out the element. Okay, so this time while using the pop method, it has chosen the element 2 and it has removed that particular element. But there is no guarantee that every time you run this command you're going to get exactly the same element that would be removed. So it arbitrarily chooses some element because like we mentioned, the sets do not have any order assigned to them. There is no indexing. So when you use the pop method, it can actually take out any element. Okay, now the other command that we have already familiar with is the clear method. So when we say my set and I mention the clear command, automatically this entire set will become a blank set. Okay. And finally, if we have to delete this entire set, you can simply use the del method. So del of my set is going to delete the entire set for us. Okay. Now let's create another set and call it my set 1. and this time I'll provide the numbers 1, 2, 4, 5, and let's say 10. And let's create another set and call it my set 2, and let's give it the numbers, let's say 3, 6, 7, 9, and 10. Okay, so as we can see, my set 1 and my set 2 have only the element 10 in common. Okay, now let's try and analyze what happens when we try and do the unions and intersection of two sets. Now that we have two sets, set 1 and set 2, we can perform those operations. Now let's begin with the union operation. So set 1, and we can say union of set 2. Now that is my set 2. Okay, so by doing this, what it has done is it has created a new set where it has elements from both the sets. Okay, now the union method, you could actually use dot union method, or the other shortcut that we have is you can use the pipe operator. Okay, so my set 1 pipe my set 2 will give us the exact same result. Similarly, now that we have understood the union, let's try and understand the intersection. Dot intersection, and here we can say my set 2. Okay, since we have already seen this that 10 is the only element that is common to both, so when we take the intersection, then we only get this particular set having one element, that is 10. And the shortcut for doing the intersection operation is the AND operator. Okay, so my set 1 and my set 2 will give us the exact same result. Alright, now if you want to subtract one set from the other, okay, so let's say I give my set 1 and I want to subtract it, so I'm saying difference my set 2. Okay, so when we do this difference, it is only giving us 1, 2, 4, 5. So let's understand what has happened. My set 1 has the elements 1, 2, 4, 5, 10, and my set 2 has the elements 3, 6, 7, 9, 10. Okay, so when you write the difference, that is my set 1 minus my set 2, then what would happen is only the elements of my set 2 which are in common with my set 1 get dropped out. So in our case the element 10 was common, so element 10 got dropped out and we only have 1, 2, 4, 5. Okay, this you could have also written as my set 1 minus my set 2, and still you would get the same result. To make this concept even more clear, let's do the opposite. That is my set 2 minus my set 1. Now if we subtract my set 2 from my set 1, then you will see that when you subtract 3, 6, 7, 9 and 1, 2, 4, 5, it is going to keep my set 2, the elements of my set 2 which are not in common with my set 1. So again element 10 will be dropped out and we will be left with 3, 6, 7, 9. Okay, so when we write this and we run, we get the elements 3, 6, 7, 9. So these are the only elements that are not common to my set 1 and are present in my set 2. Okay, there's another very interesting concept related with sets, and that is called as the frozen set. A frozen set is something which is immutable. Okay, you cannot change the elements of this particular frozen set, and you could consider it as more of a tuple. So frozen set would have characteristics of a tuple, that is, the immutable in nature and you cannot change them. So let's try and create a frozen set and see what operations we can actually perform. So let's say I create my set 1 again, but this time instead of writing as the set, I'm going to mention as frozen set. Okay, so I'll say frozen set, and inside this I'll pass in those elements. We'll create the same thing, but we'll create it as a frozen set. So my set 1, I'm going to copy these elements again and I'm going to pass it in here. Okay, similarly, let's take my set 2 and we'll create the frozen set of the same elements again. So we'll take my set 2 and we'll simply take the same elements 3, 6, 7, 9, 10. Okay, now we can actually perform the same operations of difference and union on frozen sets. Okay, so by that I mean if I simply say my set 1 dot difference, my set 2 will get the exact same output, and in output it clearly mentions that it's a frozen set. Okay, previously when we ran this it was showing it as a set, and here Python clearly tells us this is a frozen set. Similarly, if we take the union, still Python will perform the operation. Okay, but now like I mentioned in tuple, we cannot remove any element. So if I try and use this command remove on, let's say I want to remove 2 from my set 1. Okay, so if I do that, Python will throw us an error saying that frozen set has no attribute called remove. That is, we cannot remove elements from the frozen set. It doesn't permit it. Similarly, like what we saw in tuples, that we cannot add new elements to a tuple. Okay, item assignment is not permitted. So here if I say my set 1 and I say add, and let's say I add the element 11, okay, and I'm running this, again Python is going to warn us saying that there is an attribute error. Frozen set has no attribute called add, so you can neither remove an element nor add an element to a frozen set. So it is as similar as a tuple. Okay, so these are the discussions that I wanted to have with you with respect to the sets. These are the most generally used commands. Okay, so we have seen all the operations and the built-in methods.